Today I am here to describe you about the potential difference between any 2 points. This portion is lies in electrostatics or topic. So let us enter in our topic. To prove this portion potential that the potential difference between any 2 points, we need this line or this figure. It may be small figure or lines also. So first of all, what do you mean the potential difference means? Potential difference means in any point in the electric field, of the source charge. This is a source charge. In the electric field of the source charge plus Q is the source charge, which is equal to the total amount of the work done to move the unit positive charge from one place to another, which is done against the electrostatic force. That's the definitions of the potential difference between any 2 points. So to prove these portions or statement, we have to consider a source charge. We have to consider a source charge. Source charge means this is source charge which is generated by plus Q charge, and source charge in the plus Q charge in this line, yes, we have to consider source charge. Then we have to let us consider a 2 point. We have to consider a 2 point which is generated by A and B. B point lies in the electric field of the source charge. Electric field of the source charge at the distance. These 2 points are kept at the distance of A is kept at the distance of R from the source charge small r, whereas the B is kept at the distance of capital R from the source charge respectively. Source charge means plus Q charge. So from the definition, we know that from the definition of the potential difference, we know that total amount of the work done is equal to the work done to move the unit charge. To move the unit charge means one coulomb charge, unit charge from B to A, which is equal to the potential difference between the A and B. Here we can express that, in this method, like VA minus VB is equal to work BM. This means where BA is greater than BB. When the total amount of the work is done to move the unit charge from the B to A, then there will be equal potential difference will be equal to from A, and potential difference will be equal between A and B. So we can write like BA minus BB is equal to WDA. There is total work done is done. So we can express in this equation. So to find the work done, GDR or WBA, we have to consider a point P at that line. Consider a point P. Look at here. This is a we have considered this point P from which is consider point P, which is at the distance of x, at the distance of x. Look, this is a P point is kept at the distance of x from the source charge. At the distance of x from the source charge. In that P point, we have kept that 1 unit positive charge. We have kept that 1 unit positive charge. So there, then the force, there is some force will be produced. So then the force between them, so force between them means between plus q charge and 1 coulomb charge. From the source charge, force between the source charge and that unit positive charge, which is denoted by 1 coulomb charge. We can write here in the expression as F equal to 1 upon 4 pi epsilon naught into q upon x square. We can express this equation in second. Then again, if we move the charge from distance p to the q, again if we have to move the distance, we have to move the charge from the point P, charge from the point P to the, from the point P, from the point P to point Q by the small distance. By the small distance, look at it, this is the small distance which is denoted by dx. So if we move the unit positive charge from the P point to the Q point, then we have to do the certain amount of the work done. We have to do certain amount of the work done. So we can write here work is, as you know that the work formula is force into displacement, then this force F into dx. Distance means there is a small amount of distance, so we can denote it as dx. Then as you know that we have put here minus negative signs. It means that we have moved the positive charge from P point to Q point, which means we have done the work against the electrostatic force. So we have put here minus negative sign. We have put here negative sign. So as you know that the force formula is, we have taken out that force is 1 upon 4 pi epsilon naught into q upon x square into dx, which is denoted as the equation, or we can suppose the equation third. So here we have to find the total work done, means total work done from moving the point charge from the point B to A. So total work done, to find the total work done to move the unit positive charge, to move the 1 coulomb charge from the point B to A, we have to integrate the equation. We have to integration. We have to do integration the equation third, like that. Total amount of the work done from B to A. We have to do like this integration. Then work is done in small work, so we have written as from there B to A. As you know that the force density minus 1 upon 4 pi epsilon naught into q upon x square into dx. Total amount of work done dW is denoted by work done from the B to A. Then we have to these integrations from R to R. This means the point from A to B, B to A. Then we have minus Q upon 1 upon 4 pi epsilon naught into Q upon x square into dx, where we can write as R from radius R to the R from the point B to A. It means then we have common, minus Q upon 4 pi epsilon naught, then x minus 2, then it will go up, so here x power will be minus 2 into dx, then is equal to minus Q upon, as you know that the integration rule, we have minus x minus 2 plus 1 upon 2 plus 1, then here will be plus Q upon 4 pi epsilon naught integrate from R to R equal to 1 minus 1 upon x whole R to R, then we can write here plus Q upon 4 pi epsilon naught, then we have the formula rule 1 upon R minus 1 upon capital R. So from the equation first, we can know that BA minus BB is equal to plus Q upon 4 pi epsilon naught whole 1 upon radius of A from the source charge upon 1 upon capital R, which is the distance from the point B to B. So from this expression we can know that the potential difference between any 2 points. If you are the regular viewer to this channel, please do not forget to comment on 3 things. Number 1, comment on how you feel about this video. Number 2, comment on feedback on this video. And number 3, and what you like the most about this video. Keep watching my channel to know more, do more and learn more. And finally, do not forget to subscribe to remain in touch with the upcoming videos. Thank you.